Good morning, students. Uh, Today, another topic, that is molecularity of a reaction. Yesterday we have done order of reaction. This is another topic, molecularity of a reaction. Now, what is molecularity? Definition I have given. It is the number of atoms, molecules or ions that take part in a chemical reaction is called the molecularity of a reaction. I mean, how many molecules or how many atoms taking part in your chemical reaction, that is called the molecularity of the reaction. For example, suppose H2 plus I2, it gives twice HI. In this reaction, two molecules take part in your reaction, one molecule hydrogen, one molecule of iodine. So here the molecularity will be 2. Similarly, suppose Na plus Cl minus, it gives NaCl. So here two ions take part, so your molecularity will be 2. So it may be molecule, it may be ions. How many molecules or how many atoms or how many ions taking part in your chemical reaction, that is called the molecularity of a reaction. Now, one of the important question asked in your exam, the question is, what is the difference between order of reaction and the molecularity of reaction? Minimum 3 differences you should know. What is the difference between order of reaction and the molecularity of reaction? What was order? Order means it is the summation of the powers of the reactant in the rate law equation, in which the rate of reaction actually depends. And what is molecularity? Molecularity is the number of atoms, molecules or ions that take part in a chemical reaction. Order of reaction is an experimental quantity, but molecularity is theoretical. I mean, order of reaction you cannot find out theoretically, but molecularity, from the reaction you can find out the molecularity. How many molecules taking part in your chemical reaction, that is the molecularity. And another point of difference, order of reaction may be 0, may be whole number, may be fraction, but molecularity is always whole number. Molecularity never be 0. If the molecularity is 0, that means no molecules taking part in your chemical reaction. So molecularity never be 0. So these are the main point of differences between the order of reaction and molecularity of reaction. Always you remember, order of reaction is an experimental quantity, but molecularity is theoretical. Now we'll do different order reactions, mainly according to your syllabus. It requires first order reaction and zero order reaction. So we'll study about the first order and second order reaction, first order and zero order reaction. So in first order reaction, you will get one equation which is called integrated rate equation for first order reaction, and that derivation is very important. How to derive the integrated rate equation for the first order reaction. And when you find out this equation, when you find out the integrated rate equation, from that equation you can do the numerical based on this first order chemical reactions. Now I will do integrated rate equation for first order reaction. Actually, this equation is called integrated rate equation because by doing integration you have to find out the equation. That's why it is called integrated rate equation. Consider a first order reaction. A tends to P. Suppose this is a first order reaction. A is the reactant, P is the product. A tends to P. As you know, the rate of the reaction you can write minus dA by dt. This is equal dP by dt. This is equal, according to differential rate law, K of A to the power 1. As you have considered it is first order reaction, so that's why you can write to the power 1. Now in this equation you have got this equal this equal this, all are equal, so you can write minus dA by dt minus dA by dt is equal Ka. I mean I have written this one equal this, or you can write minus dA by A is equal K into dt. Now integrating both sides of the equation, integration of minus dA by A, this is equal K integration dt. K is constant, that's why it comes outside of integration. K integration dt. This is one of the standard integration and its value is minus ln A. This is equal K integration dt means T plus 1 integration constant C. So minus dA by A, this integration is one of the standard integration and its value is minus ln A. You know ln, this is natural log, minus ln A is equal kt plus C. When from this equation, when t equals 0, I mean when time 0, what about the concentration of A? That is the initial concentration of the reactant, which is represented by A naught. I mean at the starting, what is the concentration of the reactant? That is called initial concentration of the reactant, and that initial concentration I have considered as A naught. So when time 0, I mean at the beginning, when the reaction before starting the reaction, the concentration of the reactant, you will get the initial concentration. A naught is initial concentration of the reactant. So when T0, A will be A naught. Now if you put this value in the equation, minus ln A is A naught, this is equal K times 0 equal plus C. That means you have K into 0 means 0. I mean you have got the value of C. C is equal what? Minus ln A naught. Now I will write here. Now putting the value of C in equation 1, I will consider this is equation number 1. Putting the value of C in equation 1, minus ln A is equal kt minus ln A naught. This is the value of C. Or you can write ln A naught minus ln A, this is equal kt. You know log A minus log B, you can write log A by B. So ln you can write A naught by A, this is equal kt. Or you can write K is equal 1 by T ln A naught by A. If you want to convert ln to log, ln means 2.303 log. So 2.303 divided by T log of A naught by A. This equation is called integrated rate equation for a first order reaction. What is K? K is the rate constant. What is T? T is the time. What is A naught? Starting concentration of the reactant. What is A? The present concentration of the reactant. As you know, as the time proceeds, concentration of reactant always going on decreasing. So A naught means the starting concentration, beginning concentration, and A means the present concentration of the reactant. T is the time, K is the rate constant. So like this way, by using this integrated rate equation, you can find out the rate constant for a first order reaction. Thank you.